Good morning, students. Today we will discuss about the chapter Force and its effects. The chapter Force and Laws of Motion you have already discussed in the previous class in chapter Motion, different terms like velocity, acceleration, uniform and non-uniform motion. Now we try to find out what is basically the cause of the motion. In this chapter, we will discuss the basic cause of the motion. So, today's topic is the force and its effects. You know, when you have studied in motion chapter, you have studied about the motion, how the speed is increased or decreased by applying force. And you have discussed the acceleration, you have discussed uniform and non-uniform motion. But the question arises, what is the cause of a motion? How a body is moving? How a stationary body is said to be in a motion? To answer these all questions, we should know about the term, the concept of force and how are its effects. When it is applied on a body, what are the different effects arising by the force? You know, from class 8 we have studied the force. We know that the force is the pull or push. The pull or push acting on an object. So when we apply force, means when we are applying push or a pull on a body, that means we are applying force. So pull or push are the forces. Basically we are applying the force on a body. By applying pull or by applying push on a body, we basically are applying force on that body. So a pull or push acting on a body is called force. So this is the definition of force. What will happen when we apply force on a body? If we apply force on a stationary body, what will happen to that body? If a body is already moving and we are applying force on that body, what will happen? What are the effects of that force on that body, on a moving body? And these all things we are discussing in another term, that is the effects of force. You know, when we are applying force on the body, different effects are arising on that body. For example, if we apply force on a body which is at a rest, for example, this is an object, there is a body, and this body is at a rest. The body A is at rest and we are applying force on this body. Let the force F is applied on this body. If the force applied on the body is greater than the mass of the body. For example, we are applying force, the magnitude of force is less than the weight of the body. Then what will happen? This body will not move. There will be no effect of the force on that body. Why? Because the magnitude of force is less than the weight of the body. So if we are applying, the F should be greater than the weight of the body. When we are applying force F, and this F has a magnitude greater than the weight of the body, then what will happen? This force will bring this rested body into motion. So first important effect is that when we are applying force on a body which is at rest, that force will bring the body in motion. So force can bring. So we can say force can bring a rested body into motion. So this is the first important effect of force. So when we are applying force on a body, that body is at rest and we are applying force. So it is basically the cause the force is the cause of a motion. If a body is moving, because we are applying force on that body. So this is why a body which is at rest, when we are applying force on that body will bring itself into motion. And the motion, the direction of the motion of that body is always in the direction of force applied on the body. The direction of force of the body. Now the second important term. Now the question arises, if this body is already moving, if a body is already moving, what will happen if we are applying force on that body? There are two important conditions. One important condition is if we are applying force on the body in the direction of its motion. Let us consider this body A is moving in the direction shown by this arrow. That means the body is moving towards the right side. Towards the left side, sorry. If we are applying the force in the same direction, what will happen? What are the effects of force when we are applying force on this body in the same direction in which body is already moving? So here we got an idea. This force will bring, it is like that. For example, a boy is riding a bicycle and another boy is pushing that bicycle in the direction of its motion. Then what will happen? That bicycle will move faster. We can say that the body is moving faster when we are applying force on that body in the direction of its motion. So we can say that when we are applying force, when we apply force on a moving body, when we are applying force on a moving body, what will happen? And that force is in the direction of its motion. So the body will move faster. Or rather we can say, in other words we can say, the speed will increase. The speed will increase. The speed will increase. In a general term, we can say when we are applying force on a moving body, either in the direction of its motion or in the opposite direction, there will be change in the speed of a body. In the first condition, when we are applying force on the body in the direction of its motion, what will happen? The speed will increase. And if we are applying the condition, we reverse, we will apply force in the opposite direction like the of its motion. The body is moving in this direction and we are applying force on the body in the opposite direction. Then what will happen? This force either stops this body completely or it slows down its speed. For example, if a body is moving with an 80 km per hour and a driver applies a brake, that brake is an opposite force and the body either stops completely or slows down its speed. So force can bring a moving body move faster, will increase the speed, or if we are applying it in opposite direction, then the body either stops completely by that force or it slows down its speed. So the second important effect when a force is applied on a moving body, that when the force, there are two conditions. It's very important to remember when we are applying force on a moving body, there are two important conditions. One important condition is that if we are applying this force on a moving body in the same direction, and if we are applying in the direction of its motion, then the body will increase, that the force will bring the increase or change in the speed of body. That means the body will move faster because the force and the body are in the same direction. So the body will move faster or the velocity of the speed of the body will increase. If we are applying the force in the direction of motion, opposite in the direction of motion, for example, a body is moving in one direction and the force is applied in another direction, then what will happen? That force either stops that body completely or slows down its speed, depending upon the magnitude of force. For example, I have given, if a truck is moving with the speed of 80 km per hour and a driver applies a brake, and that brake will stop that body completely or sometimes it slows down its speed. Sometimes it slows down its speed. So when we are applying force on a moving body, two important effects are arising. One, it either increases the speed of the body or decreases the speed of the body or completely stops the body after applying the force. Now the third important effect, for example, force, if we apply force on a body, and that body, can that body will change its direction of motion? Yes. For example, you have seen in a cricket game, you have seen when a bowler delivers a ball that is a straighter one, the batsman, by the action of bat, by the action of force, by the direction of force, that batsman can hit that ball in the onside, offside, or in any other direction. So force can bring the change in the direction of motion of the body. We can bring the change in the direction of a motion by applying force. So force can bring the change in the direction of motion. Direction of motion. So we got an idea, another important effect of force, that force can bring the change in the direction of motion of the body. We are giving an example of a cricket ball, a cricket match. When a ball delivers by a bowler, the batsman can hit in any direction by applying force. So force can bring the change in the direction of a moving body. And the fourth important effect is that by applying force, we can change the shape of the body. We know if we take a soft ball in our hands, if we take a football or volleyball or any soft ball in our hands and we apply force on that ball, we can deform its shape by applying force. So force can bring the change in the shape of the body. Now we will recall these all effects. First of all, we have defined force, we have discussed these effects of force. Let us recapitulate these all once again. For example, what is force? So when you are applying pull or a push on a body, that means we are applying force on a body. So the pull or push acting on a body is called force. So when force is applied on a body, there are different effects which are arised. It depends upon when you are applying force on a rested body or a stationary body or in a moving body. For example, if we are applying force on a stationary body or a rested body which is at rest, that force will bring the change in the state of rest into motion. That means the force can bring the stationary body into motion and the body will move in the direction of force. Now the second important effect is if force is applied on a moving body. Here are two conditions, very important. One, if that force is applied on a body in the direction of its motion, and the second, if that force is applied in the opposite direction of its motion. Let us take the first case. If body A is moving in certain direction, and the force is applied in the same direction in which the body is already moving, then the body will move faster. The speed of the body will increase. The body will move faster. If the same force is applied on its opposite direction, that the body is in one direction and the force is applied in its opposite direction, what will happen? Then that force can stop that body completely, like the truck is stopped completely by applying brakes, similarly, or it slows down the speed of the body. So when we are applying force in the opposite direction of its motion, then that force can stop that body completely or slows down its speed. This was the second important effect. The third important effect is if we are applying force on a moving body, that force can bring the change in the direction of a moving body. We have always watching the cricket matches. We are fond of cricket matches, especially when there is a match between Pakistan and India. And we are always in front of the TV screens to watch the match there. So you see that when a bowler delivers a ball, if it is a straighter one, if it is an in-swing or out-swing, what will happen? The batsman can hit it in any direction by applying the force. Batsmen use the bat, use the force of the bat at that time to pull or the push in this ball in any direction. So the direction of the ball is changed by applying force. So we can say a moving body, which is moving in a particular direction, we can bring the change in the direction of that moving body by applying force. The best example is the cricket match, when a bowler delivers a ball and a batsman hits it in a different direction. Okay, so this is one of the effects of force. So force can bring the change in the direction of a motion of the body. Now remains the last and important effect, that is the force can bring the change in the shape of the body. We know our mothers made chapatis. When they are preparing duff and then using the ruler to make the chapatis, that by using that ruler, we are applying force on the ruler, and the duff get converted into a circular shape of a chapati or bread. So we can say, if we take a soft ball in our hands and we squeeze it, that means that we are changing the shape of that body. So there are different ways, different examples we can explain that the force has an effect. The force has an ability to change the shape of the body. Okay. So you got an idea about the force and its effects. Now, what will happen if more than one force is applied on the body? What are at that time the effects of forces on the body? For example, if we take a body, that this is a sort of bench. On this bench there is a heavy body, that this is a body on the bench, and we are applying the force on this body. More than one forces are applied on the body. For example, if a pair of forces applied on the body, for example, force F1 and here on the another direction, the F2, and both the forces are applied in the same direction. So what will happen when more than one forces are applied on the body? What will be the resultant force on the body, and in which direction the body is moving? So this is very important concept. For example, let two forces F1 and F2 are applying on the body, and these two forces are applied in the same direction. These forces are applied in the same direction. Means that what will be the total magnitude of force applied on the body, or what is the impact of these two forces on the body? Then that impact, that total force which is applied on the body is called a resultant force. That's called a resultant force. So resultant force is a force, the total impact of forces, one or more forces which are applied on the body. That is called a resultant force. For example, if we find out the resultant of these two forces on the body, the resultant force FR, the resultant force on the body is equal to F1 plus F2. For example, if this is 6 Newton force and this is 4 Newton force, and both the forces are in the same direction, then the total force applied, or the resultant force applied on the body, is equal to 6 newtons plus 4 newtons. That is equal to 10 newtons. So the total impact, or the total force applied on this body is equal to 10 newton. And this we call as the total force, the sum of the all forces, the impact of the sum of the all forces on the body is called a resultant force. Now, if the resultant force, if more than one forces are applied on a body, and you know here that the resultant force is 10 Newton, means that the resultant force on this body is 10 Newton and this body will move. This 10 Newton force will bring the acceleration, or rather we can say this 10 Newton force is enough to move this body in its direction in which the force is already applied. So we can say the force can bring the change in the this body is at rest and this force will bring it into motion. So here when a force is applied, when the force has the resultant force, and that resultant force will bring the body into motion. We can say these two forces are unbalanced forces. For example, there are two important terms when more than one forces are applied on the body. One is the balanced force, and second is unbalanced force. What are balanced forces and what are unbalanced forces? For example, if more than one forces are applied on a body and the resultant of all those forces are equal to 0 and the body will not move from its position, we can say all those forces are together balanced. We will take an example. That, for example, this F1, let the force F1 and F2 are applied. Now I will change a slight change. This F2 is in the opposite direction of F1. And here the F1 is equal to F2, that is 6 Newton and 6 Newton. So we can say two equal and opposite forces are applied on a body. Two equal and opposite forces. F1 and F2 are same in the magnitude, but they are different in the direction. One is applied in one direction and another is applied in its opposite direction. So what is the resultant of these two forces? We can say the resultant force Fr is equal to F1 plus, this will be in the opposite direction, so we will take it in a minus, so it is F2. So Fr is equal to 6 Newton plus minus 6 Newtons. So Fr is equal to 6 Newton plus minus is 6 Newton. So the resultant force on the body will be equal to 0 Newton. So that means when a pair of forces are more than one forces are applied on a body and their resultant force on the body is 0, this 0 Newton force the total force applied on this body is 0. So the body will not move because there is no force applied on the body. Will be no force applied on the body and this force will not bring the body into motion. So such pair of forces we call as balanced forces. So I can write here the balanced forces. A pair of forces. A pair of forces is said to be balanced. When their resultant force is equal to, when their resultant force on a body is 0, when the resultant force on a body is 0 and body will not move, and body will not move. Such pair of forces are said to be balanced forces. Okay. Now, what is unbalanced force? For example, we take these two forces. I will slightly change this is F1, this is 16 newtons, and this is 6 newtons. Again, we are applying two forces, but these two forces, one is the 16 newtons and second is 6 newtons. So if we find out their resultant force on the body, here, see here, the resultant force will be Fr is equal to 16, yani F1 plus minus F2, because F2 is applying in the opposite direction. So, Fr is equal to 16 plus minus 6 newtons. So that is equal to Fr will be equal to 16 times 10 newtons. So the total resultant force on this body is equal to 10 newtons. So it is greater than 0. It is not equal to 0. It is greater than 0. So we can say the body will move in the direction of greater force. Here the 16 Newton is the greater force. The 6 becomes cancelled. So the 10 newtons is the F1. So F1 is the greater force, and the body will, the more impact of this body on this body will be F1. So the body will move in the direction of greater force. So we can say when a pair of forces are applied on a body and the resultant force on the body is not equal to 0, it is greater than 0, and the body is moving in the direction of greater force. So we can say the forces applied on the body are unbalanced forces. So the pair of forces are said to be unbalanced when their resultant force is greater than 0 and the body will move in the direction of greater force. And it is obvious that the body always move in the direction of a greater force. So because the impact of the force is on the greater force, is the impact of the body is because of that greater force. So here you see that the 10 Newton force is basically the F1, which is moving this body from rest to motion, which bring that body from rest to motion, because this is the greater force. So again, I will recapitulate these two terms, these important terms. So when we are applying a pair of forces, we are basically dealing with balanced and unbalanced forces. We are basically giving an idea when more than one forces are applied on the body, what will happen on that body. So if more than one forces are applied on the body, there are two important chances to happen. One important thing, that if these two forces are applied on the body and their resultant force on the body is equal to 0 and the body will not move, we call those pair of forces, a group of forces, are balanced. They are balanced. That means the resultant force. What is the resultant force? That is the total force, the sum of all those forces on the body. What is the impact of all those forces on the body? That is basically a resultant force. So if the resultant force is equal to 0 and the body is not moving in any direction, we can say those forces are balanced to each other. We have taken an example when F1 and F2 are equal and opposite forces, and they are applying in the opposite direction, and they are equal in magnitude. The resultant force is 0 on the body because they cancel each other, and the body will not move in any direction. So this was first case. So when more than forces are applied and they are equal and opposite forces, and the forces will get cancelled, the resultant force will be 0 and the body will not move. We call those pair of forces, those group of forces, as balanced to each other, or balanced forces. So balanced forces never bring a body into motion, because their resultant force on the body is 0. Now the second important, which I have discussed, that is unbalanced force. I have quote an example here that F1 and F2 are two unbalanced forces and they are applied in opposite direction. The one is 16 Newton force, like F1 is 16 Newton force and F2 is 6 Newton forces, but F1 and F2 are in opposite direction. One is applied in the right side and second is applied on their left side. So they are in opposite direction to each other. So if their resultant force we will find, let us take an example. We take their resultant force, when we calculate the resultant force, it comes equal to 10 newtons. So the resultant force is 10 newtons. That means the resultant force is greater than 0, and the body will move in the direction of greater force. So the body will move in the direction of greater force, that is F1 force, in the direction of F1 force. So these two F1 and F2 forces at that time are called unbalanced forces. So a group of forces or a pair of forces are said to be unbalanced when their resultant is greater than 0 and the body will move in the direction of greater force. Hope you have understand the concept of force and its effects and balanced and unbalanced forces. And see you in the next class. Thank you very much.